Okay, guys, I think we did it again. Netdata supports topologies. So Netdata supports topologies in multiple levels, from your switches and routers and firewalls, layer 2, with layer 3, up to layer 7. So up to dependencies of your microservices, of your processes. The good thing about Netdata is that, let's say, it's generic. So it can do all kinds of topologies across the board. So it's not limited, for example, to Kubernetes. It's not limited to containers. It's not limited just to processes. It also supports specialized topologies like vSphere, like Cato networks. So this is a tour of what Netdata can do for you. The first thing is that you know that the Netdata is a distributed system. So you install Netdata agents on all your systems, and these collect data locally. Each Netdata agent is a complete monitoring in a box, so it's one application that has database, alerts, queries, machine learning, everything is inside the agent. And the beauty of this is that it scales by just adding agents. So you don't need a central, let's say, database that you store everything. Of course, for high availability and for supporting ephemeral nodes, we support the same software, the same agent, can be installed as a parent, can be configured as a parent. And in that case, it acts as a centralization point for some infrastructure. This, of course, does not mean that you can have only one parent. You can have as many parents as you want. And actually, we encourage users and customers of Netdata to install as many as they see fit. It's for their operational needs. It's not for Netdata requirements. Now, the beauty of Netdata is, of course, the automation. What we are trying to do with Netdata is provide enough automations all over the place, from data collection, Netdata collects everything by default, to machine learning, all metrics have machine learning by default, anomaly detection, etc., but also to dashboarding. So the idea with Netdata is that the philosophy of Netdata is that you don't have to build dashboards by hand. Of course, if you want, custom dashboards are there and they're quite powerful, but for operational needs, for troubleshooting, etc., Netdata automatically visualizes all data collected. It doesn't require from you either to know beforehand or to build that, to know which are the metrics, or build dashboards for all the metrics. Netdata provides this for you automatically. These dashboards include both single node level dashboards, so reviewing one node or one container or whatever, one thing, but also infrastructure level dashboards. So even if you have hundreds or thousands of nodes, Netdata will allow you to see, to explore infrastructure level dashboards without actually building them by hand. Now, we wanted the same philosophy to be applied to topologies. So in the last 2 years, we did a lot of work to improve the SNMP data collection of Netdata. Today, SNMP data collection, I think that is probably the most powerful out there. So you can have as many SNMP collectors as you want. It automatically discovers all your SNMP infrastructure. We support SNMP traps. Discovery runs at the rate that you want. So the idea is that in order to get started with SNMP and Netdata, the only thing you need to do is configure a network segment, the SNMP community and the credentials probably of your SNMP devices. Let Netdata discover all the devices. It will automatically collect all the metrics. We ship hundreds of profiles where we understand automatically what each device is and how and what we should collect. This mechanism will automatically now build topologies. And these topologies, there are a few philosophies, let's say, about topologies. Either You are going to build it yourself, so you are going to give your data, the data and how things get connected to each other, and you will build, like a drawing, you will build the topology yourself. Or there are some, let's say, automation tools that provide topologies by default, but are not that powerful, especially in complex diagrams. So in Netdata, we chose to automatically generate dashboards, and the relations, let's say, of devices between themselves, the kind of connections and the relations of devices determine the physics that actually make the graph, the topology graph, coherent. Now, this means, for example, in order to, we are seeing here the SNMP topology, the layer 2 and 3 SNMP topology of a demo site that we have. Now, this means that everything is dynamic, so you can move stuff, there are physics involved, and if you click the button, physics go and circle the actors and the links to their positions. Now, in an SNMP topology, here we see, for example, a small network. It has some routers, some firewalls. It has some switches here and there. So the idea is that this topology automatically visualizes all the devices that you have across your network, even if the sites, the individual devices, are in different segments, in different data centers, in different providers or whatever, that do not talk to each other. So the ability to unify the topology is a feature of Netdata Cloud. Each node knows its own part, or its data center knows its own part, but Netdata Cloud at the end unifies the entire topology and gives you an idea of how the whole looks like. Now, these topologies are quite powerful. The first thing is that, of course, you get a diagram like this. You can hover on any of them, and automatically all the connected peers are highlighted. You can click on them. So if you click on them, you can see all the ports that exist there. You can see all the neighbors, so which other devices this device is connected to. You can see all the layer 3 subnet memberships, OSPF neighbors, and all the labels of the device. Whatever we know about the device, all the indexes, ports, whatever, everything is here. So it allows you to actually see all the information of a device by just navigating these menus. Now, many things here are clickable, so you can go there. And this changes the UI. You see, this is an endpoint in this case. It's this endpoint. So the idea is that you can click on any other actor to actually, it's like a mini web browser in here. Now, we said about highlight, we said about clicking on them. Now, the next thing is that this allows you to search things. For example, if I go here and I write, I know, for example, that this is London and New York. I know that there are some routers, some switches, and some firewalls. I know that there are Cisco devices, there are Juniper devices, there are FortiGate devices, Palo Alto devices, Aruba devices. Aruba devices. So this allows you to find anything. It doesn't matter what it is. It may be a model. It may be Nexus. It allows you to find anything. And the idea is that this search is the most important thing that you have at scale. Imagine this having thousands, 10,000 of devices there. Now, these are topologies that come from SNMP, layer 2, layer 3, etc. Here, we have a few interesting options. So in this case, the endpoint devices are just a few. You see, they are added and removed by clicking this button. These are endpoint devices. Now, I'm going to switch to another topology. This is a little bit smaller. So this is the office here in Athens that we have. So this topology has mostly endpoints. So the LLDP, CDP, etc. are a few devices. Now you can select first. You can just disable them. So the actual devices that exist out there with SNMP capability are these, including that thing. These are all the SNMP devices. But now the question is, okay, can we have a map? Can we derive a map of how the endpoints are connected to this? Which endpoints are connected where? Now this is tricky, mostly because, an endpoint that is connected to any of these nodes actually is advertised by many of them. If you just ping it or whatever, it's going to be, this MAC address will be on all ARP tables of switches, etc. So here we have a way to select how you want to show endpoints. Two levels. One is high confidence. So we are pretty confident that these are there. And then low confidence means everything. Show me all endpoints, even if it is low confidence. And then we have, for this inference strategy, we have some algorithms. So what we did in Netdata is that we got all the papers that describe how you can infer where endpoints are connected to a layer 2 network, and we implemented them all, actually. So here you can switch between different inference strategies. The next thing is that what happens when you have thousands of devices. If you have 10,000 of devices, of course you can search from them. You can search for them from here. But what happens if I don't want to fetch the entire topology? So here you can select any of the known actors, any of the devices that we actually talk to, SNMP devices, and select how much depth you want around it. So you can say that I want this device with depth 3, so up to 3 hops away from it. And this allows you to actually filter the topology that you're going to see. That's one kind of topology. Topologies about networks. So this is a server. But now what we see here are containers. These are different things that are running. And if you zoom in, you have access to containers, you have access to services, and you have access even to, let me find it, even to, here they are, root, user. So processes that are running as user root, processes that are running as user Costa. Now, the same applies here. So if I say light LLM, boom, it's there. If I say DeepSeek, there it is, DeepSeek v4. So this is a GPU thing. It's an inference server. So the same way, the same functionality that exists for SNMP topologies also exists here. So if I click on any of them, I can see first the PIDs that run, etc., local IPs, processes, users. I can see how many containers C groups are running this. I can see all the dependencies this has. So what this service, this container or whatever that is, process, where it connects to, and who connects to it. and of course all the labels about whatever that is. So the idea here is that you can have an immediate view of all the processes and connections that happen on your systems. Now, you can see here that there are endpoints. These endpoints, the work that we do now is that we will use these endpoints to actually highlight threat intelligence. So to provide here information about anonymous proxies or malware or other bad actors that are relevant and your infrastructure connects to. The next thing is about Kubernetes, I think, and we have here a much bigger topology. Now, this topology, this is a Kubernetes node for this thing. Actually, you can see, so if I go here and say, for example, traffic, boom, traffic. So what I didn't say about node level topologies, IT, processes, containers, etc., is that there is a direction. Here there are arrows. So if I put it here and zoom in, you see there are arrows here, there are arrows there. So I can understand immediately who does what. That's the whole point. Who does what? And you can see here, what is important here is that you can disable all the noise, so all these endpoints, they may be, I don't know, if you check the whole of it, you see here that there are really a lot. Now, what happens is that you can disable all of them by clicking this button, boom. And now you have a topology without the noise, without the endpoints, so you can see, of course, these now appear as not connected, and the problem that are not connected is that they are usually talk to endpoints. So only the links between endpoints are now visible here. This is, again, here you can have the same thing. I think we told them, dependence and dependencies. You can have all the containers that are running about this. The same navigation inside the model exists there. You can also change this by PID or by process name, whatever you want. I prefer the container. You can also filter only TCP or only UDP, on inbound or outbound or listening sockets. So this means, and of course this is, let me enable this, I want to show you this. It's this is a quite fast visualization. So we scaled it up to 250,000 actors on one view. So if I do, for example, this, you see that this is pretty neat. It works very well. And you can rearrange them, but because of physics, they come back to their locations. So you can do some rearrangement, but physics take care of of how this settles. And this button is physics on or off. And when it's on, you see that they're continuously rearranged. What is interesting is that this works in live mode. So you can have this live mode and things move as we speak. So if I go there, you see that, and it is in play mode. So things change all the time. Probably, I don't know where. No, yes, there. So this is about topologies.